We also want to think about the integrals of some other functions that we're going to encounter a lot in this class. So for example 6, we're looking at the integral of e to the x dx. And one of the things that we remember from Calculus 1 is that e to the x is its own derivative. So the derivative of e to the x is e to the x. Which means that if I'm integrating e to the x, in other words, I'm trying to find an antiderivative of e to the x, well, it's its own antiderivative. So this is equal to e to the x, but we can't forget our plus c, because e to the x plus 2 is also an antiderivative of e to the x, and e to the x plus a million, also an antiderivative of e to the x. For our trig functions, so let's see. So we've seen power functions so far. We've seen natural log show up. We've seen e to the x show up. Let's talk a little bit about trig functions. So if we're thinking about the antiderivative of cosine, then we want to remember some of our trig function derivatives. The derivative of sine of x is cosine. And so that's going to tell me that the integral of cosine, or the antiderivative of cosine, is sine, always plus c. For the integral of sine, I want to think about a function whose derivative is sine. And well, I know that the derivative of cosine is kind of like sine. It's not quite sine, it's minus sine. So in order to account for the negative sign there, maybe I'll change up the answer a little bit, or the function that I'm starting with. If I take the derivative of minus cosine of x, I have two negative signs, one that comes from this negative sign that I've put out front, another that's going to come from taking the derivative of cosine and getting minus sine out. So those two negative signs cancel, and I'm left with sine of x. So the function that I'm looking for here, for my antiderivative of sine, is minus cosine of x plus c. Likewise, if I want to compute an antiderivative of secant squared, maybe I remember that the derivative of tangent is secant squared. So the integral of secant squared, then, is tangent of x plus c. One last example here. So for the integral of 1 over 1 plus x squared, well, we've accounted for several of our trig functions so far. Remember, this relates to one of our inverse trig functions. So one of the rules that we had was that the derivative of arctangent of x is 1 over 1 plus x squared. And so that tells me that the integral of 1 over 1 plus x squared is exactly equal to arctangent of x plus c. So there are several other functions that we haven't talked about, and that's why we have this table here. This table here describes a bunch of corresponding derivative rules with their integral counterparts. So we have here the power rule for derivatives and the corresponding power rule for integrals. Remembering that the power rule doesn't work if n is minus 1 here. We have the derivative of natural log, and we have the integral of x to the minus 1 there. Here's our exponential rule along with our corresponding integral rule. We have each of our different trig functions, sine, cosine, tangent, cosecant, secant, and cotangent, and each of the corresponding derivative rules or integral rules on the right-hand side. And finally, I've listed two of the trig functions. These are the two of the inverse trig functions. These are the only two trig functions, these are the only two inverse trig functions that you're going to need to know for the purposes of integrals. So I've included these as well. Next, we're going to talk about some of the other rules that relate to integrals. So right now, we just know how to take the integral of x to the n, but maybe there's a question of how do you compute the integral of x cubed plus x to the fifth. So we'll talk about those in the next video.